So when it comes to preventative maintenance, some of the main things that we look at is how clean is the system, because we want to make sure it's operating as efficiently as possible. Then the other thing that we look at is all the components that wear out over time. There's about a dozen or more components that will eventually wear out and need to be replaced over time. And what will happen if they're not addressed, then the whole system might go down during a busy day when the restaurant's completely full. When we come out, we're able to address all those smaller components that are wearing out. And once we get it back up to factory spec, then you'll never have to worry about the system going down at rush hour or something and you're scrambling to, hold things together. That's what we're going to be looking at today. How clean are the units? And then what are the components that are wearing out? And then also putting a plan together in order to help these systems get back up to manufacturer spec. So that's what we're going to be looking at today. Start opening it up.
Get all our pictures first, make sure everything's lined out. 10-ton train package unit.
What kind of condition is it in?
Pretty poor. Lots of corrosion.
So what's the first thing that you're going to look at?
Overall cleanliness first.
Cleanliness.
And then get belts, filters, anything like that. Start it up, start going through first stage cooling, second stage cooling.
All right, well, let's get started. All right, Taylor, what are you looking at there?
Return side. So all your air coming back in. Filter rack has no filters in it currently. Guess from poor maintenance. Try and get it cleaned up the best we can and move on from there.
So this is the fresh air intake right here. It pulls fresh air from the outside, brings it into the system, but it is not wanting to come off.
Lower wheel's even dirty. It's even worse if you get on the inside and look.
Let's see if we can get in there. Yeah, that's a beaut. Look at this bad boy.
Yeah, that's pretty rowdy.
Yeah. So what typically happens whenever we first take over a new PM, we typically have to do a whole lot of work in order to get it cleaned up and everything else. And most of the time, once we get the initial one done, we don't have to spend near as much time because from there, everything is going to stay a lot cleaner. And so we're just trying to get it back up to where it needs to be. It's just been neglected completely.
We'll send him a quote on this one to clean the evaporator coil.
Yeah,
just because it's so nasty. So if it was less, then
we could do it. You can see this is a 2017 train 10-ton. Do you ever run into very many issues with economizers?
Yeah, they break, but usually it's company error as far as not hooking them up or not installing them correctly.
How long does a PM normally take?
Say on a well-maintained system, you could probably slide through a package unit in about an hour.
About an hour. How long is this one going to take?
2, just to get it up to a decent standard. My mindset is you got to treat the commercial buildings like you own them.
So basically what Taylor is talking about is he views these systems as his, and he has a high pride level when it comes to his workmanship, and he's going to take care of them. And we do our best to preach that to our guys as much as possible. Now Taylor got the economizer clean, got this return section a lot better off than where it was. What are you trying to watch out? Oh, the pan down there?
Yeah. It's full of slime, gunk, rust, all kinds of stuff. That's our only drain pan.
I'm surprised like how small they are on commercial units.
They have a drain safety in here. You see, it's just loose in there. It's not really the right application. Really, you should have a 500E. It just got two little prongs that sits in there instead of a whole float.
So he's trying to clean out this drain pan right here because as the evap coil is doing its job, it condenses water and it trickles down into that drain pan, and then from there it's going to go to the drain line and out from there. And he's trying to clean up as much of that gunk as possible, so as water is naturally running out of it, it's not going to be pushing gunk into that drain line. So making sure that all this is clean will help make sure that it, the system won't go down or the drain clog up, and then the float switch kicks in and it shuts the system down. Now you got to call somebody out here. So he's just trying to prevent that from happening right now. There it goes.
This is what I was talking about with that float.
Yeah.
See how shallow our pan is?
Yeah.
What's that going to do for us?
Yeah.
They had it just sitting.
So it's doing nothing.
Just on there.
How long do you think this guy was riding without filters?
A couple months at least. Oh.
What?
You got to throw me off my game, Kenneth.
What'd you do? Oh. All right, so we're gauging up now.
Yeah. They have a smoke detector that's bypassed. Yeah. They took it off and they just ran a jumper on the e-stop. Not the code. Looking for any other mischievous activities. Anything else that's been bypassed, cut, unplugged, hot wires. Like that
What are those?
safety switch that we were talking about earlier. They cut that out. Apparently to use as their jumper. They had a water or fire, this thing's gonna keep running. And that's not what we want.
How often do you see stuff like this? Is this pretty normal?
Pretty much every unit that we show up to, that we
Yeah, for
haven't
the first time.
previously serviced.
What are you looking at here?
Just double checking wiring,
Oh,
seeing
gotcha.
what circuit runs to where, so we can get our inrush amps.
The condenser, usually we just spray it with water on these pans because it's so dirty and so full of grease. We have to come back with degreaser and acid to clean the coils.
So what pressures are we looking for this guy?
Nothing high. So pressures, that's all going to depend on outside temperature for your head and inside temperature for your suction.
So how does temperature affect the pressures?
Higher the temperature, higher the pressure. Lower the temperature, lower the pressure.
So how do you know how to balance the system out? Do you have like a chart that you work off of, or?
Yeah, PT chart. Run off that.
Come on, baby, fire up. So you're looking at pressures and amps. Where do you want the amps to be at?
Well, That's all relative to the system. You have to take your inrush. We look at two different amperages. Look at inrush, which is the amount of amperage it takes to start up that compressor from a locked state, and we can compare it on our data tag, and then we'll go back and check running amps, and that'll come up. Since that fan's running now, we'll dry out that coil. We're just gonna have to let it run and dry it out. This head's gonna start coming up to a normal.
Gotcha. So basically that water's evaporating, keeping it cooler than what it normally would be.
Yep. Typically let it run about 15 minutes.
Okay.
You'll get pretty good. 10 to 15.
10 to 15? Gotcha.
If you want accurate pressures.
All right, and where do you want your splits to be?
On normal system, 18 to 21 degrees. You go to high efficiency systems and we're doing dehumidification and all that. And our splits could vary. Right on the money for 20 degrees. 96 is low, but that's really what we're looking at. Sat temp, that's our indoor coil.
Oh yeah?
30 degrees.
What do you want it to be?
I'd rather have it at like 34. Anything above freezing, we're sitting at 30.
So does that mean it's probably low on refrigerant?
Good chance. We want to be down around like 16 degrees. And right now we've got 0 subcool. And that could either be from having a wet coil or just being really low.
Gotcha.
With high superheat and low subcool, you know you're low though. This one, I don't know if I'd do a leak search right off the bat because I don't know the history on it. And that could be from people putting gauges on and not putting the refrigerant that's in their hoses back in it. Do that 10 times.
Right.
We can blow it off everywhere. Oh yeah, look, we do have a leak. You see it?
So what the pressures end up showing?
Circuit 1 was low as well.
Okay, so it was low on refrigerant. We don't know how much yet.
Circuit 1 is low. I know Circuit 2 has a leak, so instead of wasting our time and their time, we'll just bid it out. So I guess previous maintenance or whoever came out here, instead of running both stages independently, they've just ran jumpers to kick on both first and second stage at the same time. And they lost half their efficiency there. Could be a bad control board, could be they had a short somewhere, maybe in their second stage wiring. They were just being lazy and didn't want to wait for stage 2 to come on. Could be all sorts of reasons.
This customer, they've had a maintenance contract with another company for a while now. And as you can see, when we showed up, the system was just completely filthy. There's no filter. The safety switch was cut. The compressors were wired together, and there's freon leaks. So essentially what they were wanting to do is for either the system to fail completely so they can get a change out, or at least get heavy repairs out of the situation. So now it's our job to fix all this. All right, so what's going on?
Non-PG, it's
Why is that?
lack of maintenance and neglect, and apparently bad technicians doing shady work.
All right, so what are we looking at? What's going on?
Long term, going back to the customer, I need 2 coil cleans, diagnosis on both those refrigerant circuits, and possibly low voltage somewhere in the second circuit. They had jumpered first and second stage. We try and get their efficiency back. If they do all that, then they'll save money long term.
Yeah.
Getting their efficiency back.